Hey guys, welcome to lesson 412, where we will continue to talk about solving equations both algebraically and graphically, and also comparing those two methods and the solutions that we get with each one. So for our first problem here, we have the square root of 2x plus 3 is equal to x. And anytime you have an x stuck in a square root, that right there is an indicator that you're going to want to get rid of the square root, okay? Because it's stopping us from getting that x out of the square root. So in order to get rid of that square root, we want to do the opposite, which is to square. So we're going to go ahead and square both sides of this equation, because of course what you do to one side, you must do to the other. So upon squaring both sides, a couple things will happen. On the left, it will simply drop the square root sign. So we will be left with just what was inside of the square root. And on the right, we have x squared. Okay, so now hopefully seeing an x squared term as well as an x term, the factoring bells start going off in your head. And you think, okay, well, we might have a quadratic to solve here. We talked about this briefly yesterday, but when this is the case, we have to have it equal to 0 in order to solve a quadratic the way that we are used to solving quadratics. So what we can do is move the terms on the left over to the right side so that we can have the left side equal to 0, and all of these things will be together so that we have a nice quadratic just like we're used to seeing. So I'm going to subtract 2x from both sides. That's going to cancel my 2x's on the left. And then I will subtract 3 from both sides. That's going to cancel the 3's from the left. So now I have 0 on the right side, on the left side, and on the right side I have my nice quadratic of x squared minus 2x minus 3. Okay, and the reason I did this is because if you guys remember, anytime I ask you to solve a quadratic, they are always equal to 0. So we had to do a little manipulation to make this equal to 0. So now we can go ahead and solve this box and diamond style. So we'll put the first term in the top left, third term in the bottom right, first times third for the top of the diamond, and middle term for the bottom. All right, it is time to find our magic numbers to fit the bill here. Two things that multiply to equal -3 and add to make -2. Hopefully you would come up with -3 and 1. Okay, because -3 times 1 is -3, and -3 plus 1 is indeed -2. So we'll fill in the rest of our boxes. And we'll fill out the outside, so x and x. This must be -3, this must be 1. So now that we factored it, we do have to go that extra step of actually solving using the zero product property. So we'll rewrite it in factored form. And this is where we set each part equal to 0 and solve separately. So x plus 1 equals 0, x minus 3 equals 0. Upon solving both of these, we would subtract 1 from both sides, we would add 3 to both sides. We would end up with -1 and 3. All right. So now that we have solved this equation algebraically, we can go ahead and take a look at solving it graphically. Next, to do that, we went ahead and split up our equation into two pieces. How did we decide on these two functions? Well, we have y1 as this one, which looks familiar, hopefully, because it is the entire left side of the original equation. So remember from yesterday that we'll make y1 one side of the equation, the original equation, and then y2 is going to be the other side of the equation. So sure enough, up here, the other side was just an x, so that's our other equation. So now that we've chosen our y1 and y2, and again, it'll always be like that. You'll do one as one side of the equation on one side of the equal sign, and then the other one will be the other side of the equal sign. to save us some time of staring at me while I graph those functions, I have just provided a picture of the graph and a picture of the table when you put that in your graphing calculator. And you will see that there is a point of intersection right here. Okay, and if we were to just follow the tick marks, you'll see that this looks like it's at about 3, 3, but you don't always want to just trust the tick marks as they are, because sometimes it can be a little hard to look at. Sometimes it's hard to make those graphs exact on our calculators when we have such close decimal numbers. So on the table, it's very helpful to confirm what your answer is. So if you look here, you got to look for where the y1 and y2 have the same number. Okay, so like here, for example, 1 and -1, those are different. All of these are different except right over here where they both have a 3. So that tells you that the point that has an x value of 3 and a y value of 3 is where these two graphs intersect. All right. So now that we have our intersection point, we can use that to find the solution to our actual original equation. Remember the difference between an intersection point and a solution. The intersection point is literally the point where the two graphs intersect. The solution is the answer to this equation. So really, it's the number that we would plug in for x in the original problem that would make the left side equal to the right side. So it wouldn't make sense to put the whole point there, but instead we just want the x value of the intersection point. Okay, x value of the intersection point. So what that means is that for us, our answer is 3, because that is the x value of our intersection. All right. So lastly, for extraneous solution, hopefully you guys might have noticed that there's a discrepancy. Okay, this whole page we've been working on solving the same equation, which was this original problem. Now when we did it algebraically, we got -1 and 3, but when we did it graphically, we only got an answer of 3. And that's what you call an example of where there is an extraneous solution. X equals -1 is the extraneous solution, because while it was a solution in the algebraic method, it is not an actual solution on the graph. All right, so any algebraic solution that's not a part of the graphic solution is your extraneous solution. I can even write that here. Pause the video to write that. All right, so here we are. It's an extraneous solution is just an algebraic solution that is not a graphic solution. So if you solve it algebraically and you get 2 solutions, but on the graph there's actually only 1, the other one is the extraneous. Okay, one more problem here. So here we have 2 quadratics equal to each other. That is the equation we need to solve, and basically the question is asking us, what could I plug in for x that would make the left side equal to the right side? So to figure this out, we should already have the factoring bells going off because there are quadratics involved. But again, just like in the last problem, we need this to equal 0. Okay, we have to have it equal to 0 to solve a quadratic. That's why we are going to do what we're about to do, okay? So just like before, we need to move all the items from one side of the equation to the other. Now we could move the left ones to the right, or we could move the right ones to the left. My personal opinion is that I'd rather move the right ones to the left, because I'd rather subtract x squared from 2x squared than the other way around. Just because if I did it, if I subtracted 2x squared from both sides, I would end up with a negative, and I really don't prefer my x squared terms to be negative. So instead, let's go ahead and subtract all these things on the right side to the left. If they were negative, we would add. It's just you just got to do the opposite. So this will cancel the x squareds. This will cancel the 4x, and this will cancel the 3. Okay, so now on the left side, we have 2x squared minus x squared, which just equals x squared. 5 minus 4 is 1, so plus 1x, and then negative 3 minus 3 is negative 6. It's not 0. Be careful there. Now here, because we moved everything from here to the other side, we are left with nothing, which means we are left with 0. And again, that's the whole reason we did this. That's what we wanted, because you can't solve a quadratic unless if it is equal to 0. So we are ready to factor this just like we always have known how. So I have my box and diamond set up here. Let's go ahead and continue with our factoring steps. So we have x squared up here, negative 6 down here, negative 6x squared here, 1x here. And again, I'm not making a point to go through this part slowly by any means because we have been factoring for a really long time. So if you need help factoring, this is not the video for you. Check out my factoring video. But what two numbers now? Multiply to make negative 6, add to make positive 1. Hopefully you would come up with 3 and negative 2. So now we can go ahead and fill out the rest of our box on the outside. X, 3, negative 2. And let's solve. So that tells us that we can rewrite in factoring form and solve accordingly. So set each one equal to 0. So our solutions would be negative 3 when we solve that, positive 2 when we solve that. So I'll just write that here all together. Okay, so now we have finished solving this equation algebraically, and now let's go ahead and solve it graphically. So again, to do that, we have to do the thing where we pick, the one side of the equation to be y1, one side of the equation to be y2. So let's go ahead and do that. All right, so I went ahead and I chose the left side to be y1. I chose the right side to be y2. Again, it doesn't matter which is which at all, so don't worry about that. And I have now, again, included pictures of the graph and the table to show you what these look like. Now we can see pretty clearly where the intersection points are, although we're going to need a little bit of help from the table to figure out exactly which point this is, because that's a little hard to see. This one, quite obviously though, is negative 3, 0. And this one, let's look over here. We can see right away that negative 3, 0 is one of the solutions, right, because both of them have a 0. And then the other one, where they're both matching, is right over here, where they're both a 15. So that other point is at 2, 15. So we go 2 over, 15 up. It's going to be about there. All right. So that tells us that our intersection points are negative 3, 0 and 2, 15. Now the solutions, remember, are always the x value of the intersection points. So we're going to take this guy and call those my answers for x, which makes sense because it's the x values and we were solving for x. And extraneous solutions, this is interesting because we have to look for discrepancies. We go up to the top and we're like, okay, when I did it algebraically, my answers were negative 3 and 2. When I did it graphically, they were also negative 3 and 2. And when that is the case, we don't have any extraneous solutions because everything matched up. Everything that we found algebraically was also valid graphically, so we don't have to worry about that. All right, that is all for today. Try the practice problems and let me know if you need any help.